So we left off yesterday learning about multiplying by factors of 10. We used a series of examples to show ourselves the pattern that we can use as a shortcut to narrow down our math problems to a basic fact, and then we can compensate by adding zeros to find the product. The last example that we did together was 4 times 700. We solved this problem by first identifying the basic fact 4 times 7. We know that 4 times 7 is 28. And then we can compensate by noticing that there are 2 zeros in the number 700, so we need to add 2 zeros to our product for a final answer or a final product of 2,800. This idea of multiplying by factors of 10 is going to come into play today as we move forward learning more about double-digit multiplication and a special way to show our work. This special way to show our work for double-digit multiplication is called the area model of multiplication. The reason why we call it the area model of multiplication is because we use actual drawings to help make a visual representation of the multiplication that we're going to do. When I think of area, I know that I think of a concept that we learned about in geometry. If I wanted to find the area of this rectangle that is 5 inches and in width and 2 inches in length, I might count squares because I know it's 2 wide and 5 long. I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 square inches as the area of this rectangle. But some of us might think of finding the area in another way. Instead of counting squares, we might notice that we have the 2 squares 5 times. Here's 2, 2, 2, 2, 2. We have 2 squares 5 times. So we might represent that same idea by the multiplication sentence. 5 times 2 equals 10 square inches. These are both ways to find the area of this rectangle. And the reason why we're calling our method of solving double-digit multiplication problems the area model is because it stems from this visual representation. We are going to draw rectangles to help us break down numbers to show our work for answering double-digit multiplication problems. This is the background of why we call it the area model. And now we're going to do an example together. In order to solve a question, a double-digit multiplication question, like 5 times 23, we first start off by drawing what's called an array. This looks like a rectangle, doesn't it? It looks like a rectangle. But in multiplication mathematical language, we don't call this a rectangle, we call it an array. So can everyone say array?
Array.
Array. It's basically going to be our visual representation of these numbers to help us solve this multiplication problem. The reason why my array has 2 rectangular areas is because I have a single digit number, 5, multiplied by a double digit number. So I need 2 columns to represent my double digit number and 1 row to represent my single digit number. So I have 1 row to represent 5 and 2 columns to represent my ones place and my tens place for the number 23. Once I've drawn my array or my rectangle, I'm ready to start setting up my problem. To set up my problem, I need to decompose my double-digit number into expanded form. When I think of the number 23, friends, how many tens do I have? Rosie? 2 tens. 2 tens equals 20. And then how many ones do I have? Kevin?
3.
3. I have 3 ones. So when I break down the number 23 into expanded form, I am left with 20 plus 3. Now that I have 20 plus 3, I am ready to set up the rest of my array. If I have 20 and 3, to represent the number 23, and I have the number 5. This is how I am going to show my work to solve the double-digit multiplication problem, 23 times 5. Now I'm ready to multiply. With my array set up, I am going to multiply the numbers that are partners in each rectangle. In this first rectangle, the number 20 and the number 5 are partners. When I look at 20 times 5, I now use my multiplying by factors of 10 strategy of breaking it down to a basic fact. I see that 2 times 5 is 10, and I need to add 1 0 because there's 1 0 in 20. I'm going to add another 0 to my answer. 20 times 5 equals 100. And now I move on to my next rectangle. My number buddies in this next rectangle are 3 and 5. And those are the two numbers I'm going to multiply. 3 times 5, when I count up by 5 3 times, 5, 10, 15. 3 times 5 is 15. And I write my answer in the next portion of my array. Now, I am left with these two numbers. These two numbers in multiplication have a very special name. The name of these two numbers is a partial product. The reason why each of these numbers are called a partial product is because they come together to make the final answer, the total product. When they are alone in parts, it's partial or part of our product, part of our answer, but they have to come together to get our final product. When I think of coming together, these two parts need to come together to show the total product. What operation do you think I'm going to have to use to combine these two parts to make a whole? What operation comes to mind? Claudia? Addition. Yes, we're going to add these two partial products together to find our total answer. So now I am going to do 100 plus 15 to help me find my final answer to our question. 5 times 23 equals 100 plus 15. When I use my mental math, I see now 100 plus 15 is 115. And this is my final answer. This is the area model of multiplication. And this is how we are going to show our work for double-digit multiplication. Let's practice it together now.